generator. Armature coil also works as a generator. That means it is going, the voltage will be induced in the armature coil. That voltage called back EM voltage. This is what you get. Correct? Let me clear everything for understanding about all these things. So this is the supply voltage, what you are applying in the armature coil. We are applying. This voltage is generated in the armature coil because it is rotating inside the field magnet coil. But field magnet coil is not rotating. It is constant. Even though armature magnet is giving a flux, that will not affect. So that's why there is not there. Now, the net voltage applied to the armature coil is VA minus VB. Another one thing is the back EMF voltage will be opposite to the polarity of the applied voltage. VA is the applied voltage. Applied armature voltage. We are applying applied armature voltage. Right? VB is the back EMF, which will exactly have 180 out of phase. That's why we put as minus. So the supply voltage minus back EMF equal to, this is VR. Okay. But I think we need to write, one step is missing. Let me write that. So here, VA minus VBS equal to IA into RA plus IA into S into LA. We know that the voltage in the inductor, correct? Voltage, actually, this is a Laplace. In current, this one I say VA of t minus VB of t equal to IA of t into RA plus LA into d by dt of IAT. This is the correct time. Note down this, because in the exam, suppose if you ask, you have to write this step also. Don't forget it. So this is the time domain equation or model. Time domain equation of the armature control motors, armature part. Please note that this part already we are not going to be a constant value. We need not worry about it. We know that phi f is constant because IF is constant, because VF is constant. We are going to do that. It will give you a constant value. It may be 5, 10, any value, some constant value that we are going to multiply. That is included in the KMA. KMA is called motor constant. Here, this IF constant also included. So that means remaining part only, we are going to vary VA. Okay. VA, if you apply, there's a VB developed, this one. Now, VB of T equal to omega into KB. Note down. Okay. In fact, you have to write it is omega T. Angular velocity of the armature. Motor speed is also varying with respect to time. When you, if you this one multiplied by KB, where KB is called a back EMF constant. Note down. Back EMF constant. For every motor, that value note. Similarly, KMF, correct? The motor constant also will be given. Motor constant, KMA. Correct? This KMA also is a constant. They're called motor constant. These two constants will be given in the exam also. If you buy this one, you can ask for the motor manager. This. Okay. Now that we have a time domain, from here you convert to Laplace. This is time domain equation. This is Laplace domain. Correct? Already told you VA can be written as VAS minus VB of t can be written VBS equal to the small IA of t is written as IAS. Actually, you can write IAS multiplied by RA plus, again, you have, I can write this IAS within bracket for understanding, but I write fully. This is IAS multiplied by S. See, within the bracket S may Laplace variable, but this you cannot remove. Correct? This is the Laplace variable which represent d by dt. D by dt is represented by S in Laplace domain. S into LA. Correct? S into LA as the LA comes in. So this is called Laplace domain. And many times, now once this is known automatically, this VB already I told you, we can write in terms of KB into omega S, where omega is the motor speed. Now, what is the voltage by VB? VB equal to KB multiplied by omega. Omega S. Omega, when applying when you start voltage, you apply, correct? You should close, you just apply the voltage T equals 0. For both VF and this one, you apply 10 volts. Here you are applying variable voltage 0 to 10 volts, correct? At T equals 1, you are applying. So at that time, whether the motor is rotating, no, shaft is not rotating. In that case, this will become 0 at starting point. Yes, please.
Sir, your pointer is not actually writing.
Not writing.
It is. Maybe the color is in white color.
1 minute. I will check.
For me, it is
Last thing I think we saw was the time, the end of the time dimension, sir.
Hello.
Yes, sir.
Yes, sir. Yes, sir. Tell me,
Yes,
sir.
sir.
Yes, sir.
No, it is visible or not? I am
visible,
writing
sir.
in maroon, correct, in maroon color.
Yes, sir. We can see that.
Last few words of the time that you were explaining, that alone was not visible.
Okay. This one you are talking about VB.
Sir, you're writing, I think, a little bit above, and that portion is not.
Okay.
Yeah,
Okay.
it is visible, but now it is visible. VB, I'm seeing it. Above the controlled DC motor, I'm seeing it.
Yeah.
Yes, sir, you can continue, sir. If something comes
Okay,
from the
fine. So that means the back EMF VB of S is proportional to omega, that is motor speed multiplied by KB, back EMF constant. When motor is not rotating, when you apply voltage, motor is yet to start. That means armature is not rotating. That time, this will be 0 volts. Correct? That omega will be 0. RPM is 0. That means 0 multiplied by KB is a constant. For example, motor constant, they say the 2. For example, manufacturer given 2. Multiply 2 will become 0 only. VB at a starting case, it will be 0. That means, for example, if I apply 10 volts, I apply 10 volts to motor and switch it on. Suddenly, I can say that at T equal to 0, I applied a step voltage. Correct? The voltage applied is 10 volts. Y-axis is 0 to 10 volts. I apply step voltage. This is what my VA. Okay, VA is applied. VA of S. Now, the back EMF voltage will be 0 at T equals 0 because the shaft is not rotating. The armature is not rotating. But as armature start rotating, what will happen? The back EMF voltage will start increasing like this. Correct? So that means the motor's omega also increasing. Correct? 0 to, for example, 1000 RPM. Correct? So this is equal to 1000. Omega equal to 1000. I'm talking. This also omega. Motor speed also expressed in the x-axis itself. Time also represents same thing. As with respect to time, the omega started from 0 RPM. Because you applied voltage, magnetic field created. Then because of interaction, motors armature start rotating. But to reach 1000 RPM, it may take some time. Correct? That depends upon J value, J and C. J and C is inertia and friction at the bearings. Will decide how long the motor will take to reach the 1000 RPM. So, but it will start from 0 only. So that means as the omega is increasing, what will happen? My back EMF voltage also will increase. Correct? It will also increase along with this. It also increase. I am showing this. This is my VB. Correct? So VB of S. So you see that now the voltage applied to the coil. Correct? The voltage applied to coil is, we call as V net. V net equal to this minus it. Applied voltage minus back EMF. At this instant, at T equal to 0, correct? V net equal to VA equal to 10 volt minus 0. So that 10 volts. What is current IA? IA equal to V net divided by. So please note that this term together is called V net. That is applied voltage minus VB divided by RA. Correct? So now 10 divided, for example, RA equal to 10 ohms. I say my RA equal to 10 ohms. Okay, I may use different colors so it will be visible. Okay, my RA equal to 10 ohms. What will happen? IA equal to net voltage is 10 volts because VB is 0. 10 divided by 10 equal to 1 amps current. Okay. Now, as speed increases, after say for example 2 seconds, after 2 seconds, my VA is still 10 volts only. What is my VB? VB according formula it become, say for example, it become 2 volts. Okay. So what is net voltage? V net voltage applied to the armature coil is nothing but 10 minus 2 is going to be 8 volts. What is my IA? IA equal to V net divided by 8. Correct? So, sorry, divided by 10. Okay? 8 divided by
Okay.
10 equal to 0.8 amps
ये
only.
वाला ये वाला पीपीटी बनाया है मैंने TFI के लिए बेस पोजीशन 4 डिग्री रोटेशन 8 डिग्री रोटेशन तीनों बनाया अभी 4 डिग्री रोटेशन के साथ वो हम जब सर यार तुमने वो ऐसा करके और वैसा नहीं पॉसिबल हुआ 8 डिग्री के साथ
Roshan sir, please be on mute.
तीनों में क्लियरेंस में कुछ ज्यादा फर्क नहीं पड़ रहा है
One
Sorry for
thing
the
I am
interruption.
very clear. Everybody just logs in. Instead of listening in class, everybody doing something else. That is the main fundamental problem with online courses that we have seen. Just log in and you will be talking something, doing something. Nobody listen to classes. That I am able to. Actually, few
No,
of
sir,
them.
that I mistake. Nothing. I'm already in the class. That is mistake actually.
No. Few of them. I said few of them.
Yeah.
I'm not saying everybody. Few of them are doing this. Yeah, I'm seeing in last 4 to 5 years, out of 30 class, only 10 students will be doing something else. Just log in for the sake of attendance. They'll be talking about something else. That's what they're doing. They're not interested, really not interested in the course. That I am able to understand. As a coordinator, I'm teaching for last 6 years. Already more than first batch 29, second batch 23, 19. Few students. I'm not saying everybody. And I don't know what is the use of joining course. Company is spending money, but you are not really looking at it. You are doing something else. Just log in, do something else. By luck or unluck, sometimes they unmute. We are able to see that this is how they are doing. Nothing more than this. And I sit and prepare. Morning I come. Today also again. What way I can say differently? I try to do. But what do you use? But I am considered more good students. Okay, fine. That's okay. But this one is when you are in class, don't do any other things. Don't do parallel processing. Your company is paying money, all this thing, but nothing is happening, but I don't know. I'm seeing frequently. Every class, somebody is talking to somebody else. Correct? If you unmute only, then only you know who and all really actually listening to classes. Okay, fine. Beyond that, I cannot tell because online course, this is the problem. In fact, sometimes the department discussing what do you use an online course. We know this is what happening. Department itself whether to continue this online MTech itself because of this only. Fine.
Sir, sorry, sir. I think it will not happen in future, sir.
No.
We will tell.
Happening, parallel, that is no use. But really, whether he is listening class instead of doing something else, if it doesn't do, you can mute and do whatever you want. That's also useless. Correct?
No,
you
sir.
can
No.
You can mute and do something else and talk with somebody just for the sake of attendance. You can show all these things, but that's not the correct to a good student.
No, sir. We are clearly instructed by all our top management. You should be available between 5 to 7. It is a clear instruction. Everybody is following, sir. Maybe 1 or 2 cases it comes.
I said 1 or 2. Just now I told you, correct? See, I am seeing you. This is the second course. Everything I am seeing you personally, all of you, correct? Really interested. You are sincere. A few of them are doing that. Disturbs the entire classes. It creates a totally different this one. No, if somebody listens, for example, a dean wanted online. I want to see how it works because he asked me, give me the link. I will also watch. Suddenly ask if this is what going, what he will think.
Yeah, we'll make sure, sir. We'll make sure that the team participates fully in the classes. There may be one or two, maybe instance, maybe due to the deliverables or urgent deliverables, they may have looked into that. But we'll discuss with the team and we'll make sure that the team is fully involved in the class, sir.
Yes. Thank you. Kind of. See, I am not angry. See, please know that I understand because you are working all those things, but otherwise you won't really consider learn things. That's what. Nothing more than that. See, I am one is as a teacher, I am little angry. Maybe somebody disturb in between, but as a coordinator, I look like you only. Correct? You have other this one. That I know. I see. As per me, it's kind of two angles. One is a coordinator, other is a teacher. No teacher likes somebody talking in between. But as a coordinator, I understand that you are delivering because yes, you may be talking somebody urgent call, something like that. But generally try to avoid this contact and listen to the class. That's what I advise. Yes, this one. As a teacher, in between nobody should not talk.
Just
Okay,
a
don't worry
clarification.
about that. This
Just
not
a clarification, sir. Just a
Huh?
clarification. Basically, it happens sometimes that mic is like on accidentally, and since we are in an office room, so if neighbor is talking, the mic catches that. So it might be.
No.
Just keep that in mind, sir, because
No.
we are fully in the
See,
class.
I understand,
We are fully in the class.
Roshan. See, somebody talking different, you yourself talking to somebody else in the class hour.
Yes,
That's
yes,
what
yes.
we're doing. Nothing
Right,
more than
right.
No, it is. Please note that I am really not. I am really trying to advise you, help you. Correct? I told you last week when lab class also I told you, no, you are working 8 hours. Beyond that, you are trying to attend. Already you are tired, so tired. Correct? You have so many things pending. Really, I know. Because I have worked in industry for 2 years. Right? I personally work in industry. I know how I work long hour. Every day meeting will be there. All those things. I really understand. That is okay. But it interrupts the class. That's why it doesn't look nice. Nothing more than that. Okay. Fine. Don't worry about that. This is very simple. This is advice only. Don't relax and listen to the class and go on. Enjoy your weekend also tomorrow 3 days. Don't worry much about it. Just advice only. Okay. Fine. Okay. Now the vacuum is developed only in case of if I try to vary this one armature control. So the equation is written here. Okay, and it is fully expanded. VB is expanded KB into WS but it's going to opposite sign of the applied voltage. That's why the net voltage is difference between applied voltage. This one, according to that, this is the equation. Once this is the electrical part, correct? This is my electrical part. The electrical part generate TM, correct? That TM is given as the input to the mechanical part. That is here, correct? Shaft speed, motor speed is omega is taken as the output. Output divided by input equal to 1 by J into divided by S plus C. This one is same because this is the moment of inertia of the armature. This is bearing frictions or any other friction opposing forces. This is the mechanical part. So now the final this one is I apply input voltage. This is called functional block diagram. I told you one small thing because you can see here is which was not there in this is this feedback loop. This is called a feedback loop. Correct. So the feedback, this is back EMF. This is omega. What is here? This is nothing but VB. What the output here is nothing but VB. VB equal to omega, correct? Yes, multiplied by KB. Correct? KB multiplied by omega, that is back EMF, that is applied here. So here the output is the net voltage, V net, no doubt. V is the supply voltage, but that voltage is not going to be there. As the motor speed increases, what will happen? The motor speed, see, this is what I told you, applied voltage VA, you applied 10 volts at T equals 0. My motor speed, back EMF is increasing, correct? Back EMF is increasing something like this, right? It goes to this. And but it will never touch. Back EMF is designed such that it is lower than the maximum set voltage. VA, say, VA can be varied from 0 to 10 volt. That was motor manufacturer told. So VB will be maximum voltage. VB max will be maybe 8 volts or 7 volts, something only, not more than that. Why? I will tell you. Correct? We know that VA minus VB divided by R is the IA. Correct? VA initially 10 volts. When motor was just started, KB was 0 divided by this is 10 ohms equal to 1 amps current. This is my IA. Now motor speed is picking up. Correct? Motor speed is 0 to I said 1000. Correct? Say it become 200 RPM. 200 RPM is the VB may be 1.2 volts or 1.4 volts. Okay, but what voltage you are applied is 2 volts, correct? Because the 10 volts already there. So that means 10 minus 1.2 divided by 10 is my IA. Now you can see the 8.8 divided by 10 equal to 0.88 amps. So as the back EMF is increasing, the difference in this is the net voltage, correct? This is what the difference voltage, V net. V net will be go on decreasing. Okay. That means, for example, at 1000 RPM, my VB at 1000 RPM, my VB equal to 8 volts. That's what the motor may. If we can make 110 also, but your motor will not run. If I say maximum is a VB equal to 8, then what is my IA? IA equal to VA minus VB divided by 10 is nothing but 10 minus 8 divided by 10 is 2 divided by 10 is 0.2 amps. Correct? We know that already the motor torque developed by the motor armature current TM equal to KMA multiplied by IA. Okay, I say that my KMA equal to say I can say that KMA equal to, for example, 2 for example understanding purpose. Okay, so this is going to remain constant, but my IA was varying from 1 amps to correct? It is come to 0.88. Correct? So when it goes 8 means 0.2 amps. So that means this is 2. This is varying from initially 1 amps. So maximum torque, starting torque, as the motor speed increases, the back EMF is increasing. Back EMF at 1000 RPM, I told you it is 8 volts. 10 minus 8, 2 volts divided by RA equal 10, then current become 0.2. So that means I can say that initially the torque was 2 Newton meter. Correct? When back EMF 0. But as the back EMF 8, the current become 0.2, this one become 0.4 Newton meter. Correct? At motor is running at 1000 RPM, the torque become 0.4 Newton meter. When motor was just about to start at 0 RPM, the torque was maximum. So that means while designing the motor, correct, armature control motor, the manufacturer decide that VB is always lesser than VA. Correct? How much lesser than this depends on how much torque you want. At full speed, what torque you have to do. Correct? Initially, more torque will be there. As speed increases because back EMF, the motor torque will reduce in armature control. So, what is the this one? If I say I want my motor at 1000 RPM, I want say 10 Newton meter torque is needed. That means initial torque will be much higher. Correct? Based on this, the VB value, how much VB should generate will be decided by the manufacturer designing. Take care of that. I think with this we'll do. Now, we have the transfer function. This is the functional block diagram. This you can note down called V net. Correct? So I apply VA. This is my VB of S. This is equal to VA of S minus VB of S. Okay. That is given as input to the electrical model. Electrical model or transfer function, which is 1 divided by LA divided by S plus LA, RA divided by LA. Then what is the output? The output is IA. Correct? The current is supplied to coil. Correct? We supply VA equal to, for example, 10 volts. IA is flowing. That is supplied to coil. Because of that, yeah, VB is generated in the coil. Correct? That is proportional to KB into omega. That is here. This is called motor constant. The motor constant multiplied by IA is going to give T motor torque. This is the output of the electrical system. That is given as input to mechanical system. Transfer 1 divided by this one is going to be WS. So when you give the feedback, so this is my output, motor shaft. And also torque is there. It also develops shaft torque. I can say that TS is called as shaft torque. This TM is called the motor torque. Note down. The motor, that is also motor torque or motor developed torque. It will be always greater than motor shaft torque. I say SH. Why? Because of this friction, all this thing, correct? Inertia, all this thing consume some amount of this is called as net torque. We say that T net finally available to drive the motor is nothing but Tm minus, that is also called a T shaft. Some books call it T net, some book call it that be as a T frictional. Frictional due to moment of inertia and the friction in the bearing will reduce some amount of the torque. Correct? So remaining only will be available for driving the load. Okay. So any questions in this before going next?
Sir, this is usually used because I recollect seeing some calculations like this for our use also in medical level. So now, sir, I am really sorry for asking an off-topic question. But
no question out of topic. Everything relevant. You are an engineer. I am also engineer. Ask any question. No problem.
Thank you, sir. That really helps. So, like, sir, you know, we have two levels of torque, right? Like one at an axle level and one at a vehicle level.
Okay.
So now the difference, now when we calculate that, how do we measure this friction torque as such, sir? Because
see, for example, you have, for example, you have engine, correct? Yes, engine itself produces some torque. Engine torque, I say TE, correct? That is what produced due to the combustion, the pressure, correct? Inside combustion upper pressure, downward force, all those things. That will not be available on the shaft, correct? Yes, right. Engine shaft will be still less. There are bearing friction, correct? Air will be going with some if the motor air will be in case engine, this friction, bearing friction, all that then also piston frictions, all those things will consume some amount of this one. So the available on this shaft will be lesser than TE. Okay, this in turn is given to gearbox. Gearbox also you have friction. Then yes, you are given to transmission. Yes. Transmission system has a friction. Then it goes to differential, correct? Finally, it goes to axle, correct? To wheel. Okay. So every stage there is a friction.
Okay, so the combined force, whatever we are reducing due to friction at each level, will be the total friction torque.
Total friction. Next semester, I will be teaching about the hybrid electric vehicle. That time I will talk all these things. How to all these things will talk. That course I am covering this.
So it is something like how we calculate well wheel efficiency, something similar.
Yes, exactly. Because everywhere there are losses. The produced torque at the engine, correct? Maybe 100 Newton meter, correct? Okay. For your engine. Finally, available wheel maybe 90 or 95 or 85, correct? But how much you lose the bearing, that's why you lubrication, the bearing design, all this thing matters. You want to reduce all the frictions so that all torque will be transferred directly to axle. That is not possible.
Okay.
So not only engine friction, gearbox friction, transmission friction, differential friction, all this thing will consume little torque produced by engine TG. Okay. Now next we will go to your next important.
I have a question, sir. Sorry.
Yes, please.
Sir, this omega s upon Tm s, the question number 3 from the top.
Which one?
The question number 3 from the top, sir. So if I try to just check this equation dimensionally, so if I cross multiply Tm divided by J is equal to nothing but alpha, right, sir?
Acceleration.
Right, angular acceleration, right, sir?
Correct.
Now omega s into s plus omega c divided by J. So if I convert this whole equation into time domain equation, so it will become T in the function of time divided by J, which is nothing but alpha. Then d omega upon dt, that is nothing but alpha again. But c omega divided by J, this omega is the angular velocity, and c into omega is valid. Like c into v should be the real equation, if I'm not wrong.
Shall we check next class? I will tell you.
Right, sir. Please.
I will verify. Thank you very much. Kind of you. Okay, I'll just dimensionally verify. I'll come back to you.
Okay, sir. Thank you, sir.
Maybe while typing, Mr. I'll just verify and come back. Okay.
Okay, sir. Okay.
Thank you. Kind of you. Okay. Next important in any mechanical system is gears. You know, correct? Every machine, robo, any machine, CNC machine, wherever. So wherever you wanted to transmit power from one shaft to another shaft, correct? And then you'll be using gears. I call gears as mechanical transformer. Correct. We know, just before continuing, I want to say that if you take an electrical transformer, it has two coil. One is called primary coil. There's a core. There's a secondary coil. Correct. In the primary coil, you are applying a voltage, AC voltage. Correct. For example, I am applying 100 volts AC, and the primary coil has, say, N1 number of turns. Secondary coil N2 number of turns, and secondary coil is connected to a load. For example, resistive load R. Correct. In which I want to supply some power. This is my resistive load R. Now, we know that once you supply voltage to primary coil, circuit is closed, there's a current flow. This I call as VP, and this voltage it is VS. There's a current called IP. Because of VP, there's a current flowing in the primary coil IP. Because of that, the transformer generates magnetic flux. You know that. It creates magnetic flux. I say pi P. This magnetic flux will go on link on the secondary coil also. So it's going to cut. So because the magnetic flux is cutting the secondary coil, this will induce a voltage what we call a VS. Correct? What is the VS value? Because the voltage you are applying only primary, and there's a voltage appearing secondary because of magnetic coupling. It is called as, note that in electrical transfer we call as magnetic coupling. Okay, magnetic coupling, because there's a phi F, phi P. This phi P go and links the secondary coil. Secondary coil has number of turns. We know that number of voltage produced in the secondary coil is proportional to N2 into some constant. Correct? Some constant. What is the constant? That is called as transformer ratio. Transformer ratio in a transformer is nothing but N2 divided by N1 is called a TR. I say a short form TR. Transformer ratio transformer is given as N2, where N2 is called number of secondary turns, N1 is called primary turns. Once you know these two things, automatically kind of transformer ratio. So we can say VP into IP equal to VS multiplied by IS, where VP is the primary voltage, IP is the primary current, VS the secondary voltage, IS is the secondary current. Secondary current is flowing in the secondary coil. This is IS. Okay. Now, the VP and VR are connected by N1 by N2 divided by N1. So, now, how to find out? We know that VS equal to TR multiplied by VP. Okay. Now, similar to that, in case of mechanical systems, okay, in the mechanical systems, we have what you call as gear. Gear, you know that there's one gear I called as input gear or driving gear, other one output gear, driven gear. Right? This is output gear, this one. Now, according to this figure, if we can see that the gear ratio, correct? Already all of you know gear ratio can be given this formula, where T1 is the number of tooth in first gear, T2 number of tooth in the second gear, correct? And theta 1 is the angular displacement, theta 2 is the angular displacement of the second output gear, correct? Output gear I call it as 2, correct? This I call it a 1. So the subscript says that T1 means number of tooth in the secondary or output gear divided by input, and N2 is this RPM. The TR can be written, not TR, it is a GR. Extremely sorry, it is GR. Gear ratio can be written in any of the terms, correct? If you know number of tooth in the driven gear divided by number of gear, this one, or displacement. Theta is the displacement degree of the input gear divided by this one, or RPM of the output gear your input, or radius of the gear. If you know, you can always find out. So why I am calling this as mechanical transformer? We know that in mechanical system, the power P equal to N into T. Okay. Now, for example, this gear is there. This gear is rotating at the N1 speed. The output gear is rotating N2 speed. Okay. Now, we know that N1 multiplied by T1, and I am giving a torque to the, because the gear we have to write. Please note that I have the prime mover. It can be motor or engine or any other rotating actuator, which is coupled to the driving gear, or because of that, the driving gear is running at N1 speed, RPM. Then I am supplying a T1 is the torque given by this. This should be equal to P2, which is nothing but, both should be equal. Is nothing but P2 equal to N2 into T2. Okay. Now, if I say N1 is 1000 RPM, correct, and multiplied by T2 equal to 50 Newton meter, that should be equal to, if N2 is, for example, 500, right? Then T2 should be 100, correct? So we can see that these two should be equal. Input power should be equal to output power. Now, because of from this, what we understand is, if my input shaft is rotating at 1000 RPM, input torque is 50, then the output, if the output speed is less, correct? How much? Less by 2 times. That is, then the torque will multiply. Now, input speed is higher, the output is exactly half. That means input torque is 50, output torque will be twice. So that means I can amplify. I can say that gear is called a mechanical. I call it a mechanical amplifier. Like electronic amplifier, I can call mechanical amplifier. Right? How much it will amplify depends upon the gear ratio. Gear ratio going to decide this. This is how we can. So this is what I shown here. Now, if I talk about displacement, input gear, how many degrees it is rotating. So for example, it rotated 30 degree, and how much will be theta 2. That depends upon the N2 divided by N1 divided by N2, which is called a gear ratio. So I can say that gear ratio times multiplied by theta 1 will be equal to theta 2. Correct? So this is called a gain, or gain. Similarly, at the same time, if I wanted to talk in terms of because I'm giving input RPM and also torque. Instead of that, I want to talk in terms of torque, means the gear ratio is N2 divided by N1 is called GR, multiplied by T1 equal to T2. Okay. So you can see that the gear ratio is opposite. Input gear number of speed divided by output gear when I talk about displacement or angular velocity. If I want to talk in terms of torque, input torque multiplied by gear ratio, here gear ratio N2 divided by N1, here N1 by N2, here N2 divided by N1 equal to output torque. How much torque I will get? So that's why the gear works as a mechanical amplifier. Shall I give some break for 5-10 minutes? Continue.
Sir, yes, sir. Yes, sir.
No, because
Just 5 minutes,
nobody can sit continue. After now it is 5:55, 6:10 or 6:05 will we start? 10 minutes?
Yeah, 6:05 will start.
6:05
Yes,
will
sir.
start.
Sure,
Thank
yeah.
you.
Thank you.
Thank you.
So do you celebrate Navratri?
Navaratri, south it is very less, except city, people down there, but they do the Ayudu Puja alone. Especially
In
Tamil
IIT,
Nadu.
I think in IIT campus there is a Garba, na, if I'm not wrong.
Yeah. Here, no. Here you see, if you see the population, student, see 10,000 students, correct? Faculty around 600 faculty, correct? Staff another 2,000. Out of that, at least 60% is from north. Correct?
Okay.
North, it is very popular. No, Navaratri, one of the important celebration. West Bengal, Gujarat, Rajasthan, everywhere, it is very
But
important.
what I heard from Rahul is like one of my batchmate of BMET lab, that in Tamil Nadu, the Navratri festival is having their own importance, and you celebrate with a different flavor. What is that actually? Like you make some idols and like any rituals like?
Generally, because that's what I see. I am coming from rural village, small village. My native place is very small village, correct? Around 200 houses, correct? All are farmers. Most of the people are farmers. Now, current generation, nobody is there to do farming. All are now barren land. Everybody's son, daughter become doctor, engineer. All gone to city. My village feel like a ghost, correct? Only old people are there. 60 years, 70-year-old people only there. And they also cannot do any agriculture. Correct? Lands are not used because agriculture become declining. But I do this even now. Only in city they celebrate these 2 days, all those things. But otherwise, except Ayuda Puja, celebrating Saraswati Puja, it may be one day affair or this one, not like north. That also will not very palm.
Okay.
Here, mainly, if you take Tamil Nadu, Pongal, Makar Sankranti.
And ours is Makar Sankranti on that day.
Yeah, that will be one day only. Here it is 4 days. Correct? They celebrate 4 days like this one. Next one is, in fact, if I am this one, if I want to tell the truth, Diwali also not very important Tamil Nadu for last to my knowledge. Correct? Except kids, you can fire crackers. In village, nobody doesn't bother about Diwali. Only thing is they put a new dress and the kids will fire cracker because that's what I did. Correct? Otherwise, no, not much festivity. Morning, they go to temple little bit, not very seriously. Main festival in Tamil Nadu is Pongal. But now the Diwali also gaining popularity slowly, little more. And the other one important is the Ganapati festival, correct?
Right, sir. Right, sir.
It was nowhere in our eyes. Nobody bought this one. And my village, nothing. When I get the call, one day holiday, nobody bought except few people go to temple. Nothing more than that. But now it become a big, putting big the idols, street corners, entire Tamil Nadu, everywhere. Now for last 20-30 years, now it is also become very popular. Right? People now celebrate very serious this one. Diwali, Vinayaga Chaturthi, correct? These are now gaining much popularity in Tamil Nadu also, in southern state also. But you know, this is one way to relax. No, you.
Right, sir. Of course.
One thing is religious, other one is also get relaxation. Correct?
Yeah.
Really, religion itself to reduce the mental pressure. No.
Of course, sir. Of course.
When you are in a very difficult situation, nobody can help. Correct? You need some solace, some this or no. So for that only religion. Correct? And if it helps you reduce a burden, this one no, that is really very important. Celebration is very important.
Right, sir.
So you was already holiday or in your company or?
No, sir. We don't have any holiday on like because typically in Maharashtra, sir, they will give the holiday for Vijayadashmi, which is falls on the
Saturday.
Like right, sir.
Same, IIT also only Vijayadashmi only.
Yeah, it's
only
a
one
holiday
day
already, so there is no special holiday actually.
Same for us, no. This year, no, Vijayadashmi also, since it fallen on this one, Saturday, it became regular weekend, nothing more than that. But, okay. But Gujarat and all, they give Navaratri more, correct? 3-4 days and all.
Yeah, sir. In Bihar, West Bengal,
Gujarat.
UP, and Northeast like Assam, and these states basically, the Navaratri is very prominent festival.
Durga Puja, Navaratri, all those 4-5
Right,
days
sir.
they celebrate.
Right.
Very serious. 9 days, but at least 3 to 4 days they take minimum.
Yes, for sure. From Ashtami to Dasmi, like 3 days.
Okay.
Yeah. 10 days, the Garba will be there.
Oh, 10 days.
Yeah.
Oh, I think we should go and work in Gujarat for 1 or 2 years to get 10-day holidays.
Even like the Uttarayan during the Pongal time, they'll celebrate Uttarayan. We call it as
They call Uttarayan or Makar Sankranti.
Sagar Sankranti. In Gujarat, they used to fly with kites
Oh.
actually. Wonderful to see.
Oh, okay.
Sir, what I gather from like what I mean to say from my Tamilian friends that there are a lot of Devi temple in Tamil Nadu also, if I'm not wrong, right?
Every village.
So if so is the case, then is there any special puja for Devi on Navratri? No, nothing like that.
Nothing special. No, see, here Devi considers, you call Durga, correct? Here they call Mariamman. Mari means rain.
Okay.
Tamil, pure to Tamil, they call Malai, but actually another is a Mari. Mari means rain.
Okay.
Correct? Because they say that if you go and pray to, if there's no rain is there for a long time, drought, correct? Each village people, ladies will go and make pongal, like Makar Sankranti. They in front of Devi temple, they cook there itself, pongal, and pray that rain should come. That's why she is called Mari Amman. Amman means mother. Mother, that is a rain god, a rain mother, you can say. Durga is considered, every village you have a temple, Mariamman temple. Small, it means generally large, but there are big temples, very big temples in near Trichy called Samayapuram. There are many temples are there, Durga temples, correct? But every village definitely will have this Mariamman.
Okay.
At least one temple, minimum temple, whether other temple is there or not, Mariamman temple definitely be there in every village. Every village you will have. Very, very small, but they will go and pray this one. They call a family deity for some people. It is there. Every village is there. You are true. Big temples also is there. But generally, she is a consort of Shiva, no? So each Shiva temple, this is always there. They call Parvati. In Tamil, they call Parvati.
Yes, Parvati.
So if you go to any temple, correct, Brigadiswara temple, Kanchi, you are around at least 100 big temples, correct? I am talking 1,000-year-old, 1,200-year-old, 1,500-year-old temple, at least 100 big temple for Shiva in entire Tamil Nadu. Each temple, a consort will be there, no? Nearby, inside temple is one is Shiva as a linga. Nearby there will be a separate temple inside the premises for the Durga. They call Parvati temple, Amman. They call Amman.
Yeah, Madurai Parvati Amma.
Parvati Amman. Meenakshi Amman.
Meenakshi Amma, yes. Meenakshi is the counterpart of Lord Vishwanath in Kashi.
Yes.
I have seen many
Vishalakshi. In Kashi, they call that as Vishalakshi.
Kashi, yeah.
In Kanjipuram, they call Kamakshi. In Madurai, they call Meenakshi. These three are very popular. Kashi, Vishalakshi, Kanjipuram, Kamakshi, Madurai, Meenakshi. Very popular.
Sir, shall we start, sir?
Yes, please. Thank you.
Thank you, sir.
Yeah. Okay.
So maybe you can have some water also, so we can wait for that, not an issue.
Okay. Now we have seen gear. What is use of gear? The gear job is mainly as a power transmission system. It can amplify the RPM or torque generated by the motor when it is connected to load. Correct? It acts as intermediate system. So now we see an example for how the gear is useful in driving a load where you wanted to amplify torque or speed. So the gear system, I have a motor. Motor has a rotating armature. That is this. That shaft is, this is the armature shaft or motor shaft. Okay. And it has a moment of inertia, IM. I call motor shaft inertia. That is, sorry. connected to gear. This is my gear system. This is the driver gear. This is the driven gear. Driver gear is connected to motor and it is connected to the motor through a bearing. So bearing has a damping friction, right, which opposes. That I call KDM, motor damping. This is motor inertia. And I have the gear. Gear has a gear ratio, GR. Correct? There's a gear ratio, GR. Then output shaft is connected to driven gear. Correct? That is supported by bearing. The bearing has a damping. I call it as output damping. O means output. Output bearing damping constant is KD. Then this is my load. Load mass or driven mass. It has an inertia I0. Now that my system is distracted, now I wanted to write the mathematical model of this motor driving a load through a gearbox. Already we know that gear ratio equal to this is theta m, this is here theta out. That means output gear which is connected to load, angular displacement I call theta out, and theta motor is this motor. This is theta motor. How many degrees motor is rotating? That can be out. So this divided by this angular displacement of load divided by angular displacement. Motor is called a gear ratio, GR. Again, we can write this. If I wanted to find out the velocity, what I do? D by dt of the angular displacement of motor equal to omega of the motor speed. This is nothing but RPM. Right? D by dt of angular displacement is angular velocity of the motor. Similarly, I know the angular displacement of the output or load. So d by dt of that is nothing but output load velocity omega m. Now I can write gear ratio in terms of this one also. Gear ratio I can write in terms of displacement or in terms of velocity also. Output shaft velocity or load velocity divided by motor velocity is gear ratio. We know that. Then we know the omega the angular velocity means alpha is by angular acceleration. Alpha equal to d by dt of omega. That already we know. Right? From this I can always get alpha. Now that we know, another thing what I want to note that please take this very well because this is a derivation. You may be exam, you have to derive the equation and once values are given, you have to compute something. So please take each and every step very important. We know that power is omega into T in mechanical system. There are two power. One is input power. I say the motor power. PM equal to omega m into Tm. Similarly, the output power P naught equal to, which is acting on the load, is nothing but omega naught minus T naught or T out. Okay, I can say the T motor, torque motor. So since we know this, we can write that already in the previous slide also told you, PM should be equal to P out. That's what we have done here. Again, I am giving you this is the acceleration, this is the velocity, and gear ratio can be written in terms of displacement or velocity or acceleration. All are same. Omega out divided by this one is going to be there. Then this is nothing but PM, P motor equal to P output. Omega motor speed multiplied by motor torque equal to the output speed or load speed multiplied torque at the load. T out is torque at the load. So then we can write from this, I can always write T out. If I wanted to find out what is the torque needed to drive a load which requires T out, I say that a load required T out is load torque is 10 Newton meter I want. I need to select a motor which is driven through a directly not driving. If you directly driving, you can know that T out should be equal to T motor. No question about it. Already, otherwise the load will not move. So I need the maximum torque at 10 Newton. The motor also produce, that is well known. But I have a motor which has less torque. but it can run at higher speed. Motor can run at higher speed. There are two things. Again, note down. This equation is talks about input power equal to output power. That means this is motor torque, this is load torque, this is motor speed, this is load speed. Okay. Now I have a load which required T out equal to 10 Newton meter. Okay. And my motor, T motor is only 5 Newton meter. Can I drive this load? Load required 10 Newton meter, but motor torque only 5 Newton. Can I drive it? Of course, you can drive, provided you have intermediate gear. That is what the gear is there. Only one problem what you will face is, if motor speed, T motor equal to, for example, 1000 RPM, maximum speed, the load, T out, load torque cannot be more than 500, sorry. This is omega. T motor equal to 1000 RPM, correct? In that case, my omega naught, this cannot be more than 500 because the gear ratio can be calculated, correct? Gear ratio can be calculated from this. But because of the gear, if torque is to be increased, motor torque is only 5 Newton, I want to double, correct? I want to double the torque, then only because my load requires 10 Newton meter. In that case, the gear should reduce the speed, then only torque will amplify. Already we know that. That's what this equation itself. Input power equal to output power. Input power equal to nothing but the motor speed multiplied with motor torque should be equal to load torque, load speed multiplied with this one. So automatically you can see that the T motor can be computed using this. Okay. If you know the gear ratio, automatically you can multiply with the gear ratio. Okay. How much torque is needed? I can find out if I know the output torque and I know the gear ratio, how much with the motor's torque it need. So you can select this motor. Okay. For that only now, from this equation, now we will write the mathematical model. This is the mathematical model of the entire system. We are talking about modeling the mechanical system. Please note that we started with spring mass damper, spring and damper, spring mass damper. Then we talk a hydraulic motor, hydraulic cylinder controlled by this one. We saw mathematical, how to develop mathematical mechanical system controlled by some actuator and valves. Now here we are trying to find this one. We know that T naught torque of the output. Here, this is the T naught. Load torque equal to the load moment of inertia multiplied by angular acceleration. Alpha is angular acceleration. So that can be further written as I naught into alpha motor multiplied by gear ratio. Correct? So from this, I can write that Tm, torque of the motor equal to T naught, torque required multiplied by gear ratio, which can be written as I naught into alpha m into gear ratio square. Okay. So from this, now we can consider that because we are talking only torque, but there is a this one friction which is going to consume some torque, and that should be taken care. By considering damping also on this shaft, output shaft, what we can write T naught equal to KD naught into omega naught, which can be written as KD naught into omega m multiplied by GR, where omega m is motor, omega motor you can write. This is out. So gear ratio time motor speed multiplied by damping. Correct? Damping at the output shaft. KD naught is output shaft damp bearing friction will be equal to T naught. Okay. Similarly, I can write Tm equal to motor torque equal to output torque available at the load multiplied by GR, which can be written as KD naught in omega m into GR square. Now that we have individually we have found, we can write total equation. Who is generating torque? The motor. That is my input. Correct? Input is the torque developed by motor. That is given as input to the gear and finally it goes to the load. So I can write this equal to Im into alpha m, correct? Im is the moment of inertia of the motor multiplied by angular acceleration, alpha m, plus, correct? Kdm is the damping or the bearing of this one multiplied by omega m, correct? So this plus the gear ratio gr multiplied by T naught. Okay, already we know T naught equal to I naught into alpha naught and Kd naught in this one. So by substituting this value here, what I can get this equation. Please see this step by step. Please take the notes. Okay, this is basically this one in which I am substituting each and every one where gear ratio is we are keeping. T naught can be written equal to moment of inertia of the load multiplied by alpha naught, angular acceleration of the load, plus damping constant, the damper, which damper are bearing friction at the output side multiplied by angular acceleration omega naught of the load. That can be substituted here. If you substitute that, this equation becomes this equation, Tm equal to alpha m. Now what I can do is in this one I can Tm again rewrite Tm equal to Im into alpha m, Kdm to organization, gr we can write it. See, already we have here gr square, right? So this I can write like this, gr square and IAM and gr square Kdm. So now I can take everywhere wherever alpha m is there, I can take it out. Correct? If I take alpha and those term alone, I will do Im is there, and the next one is gr square into I naught. This term will come here. This term is coming here. Okay. Then I take omega m, motor angular velocity. The Kdm will come here, and this Kd naught, this will come here. So by separating the terms which has alpha m and omega m, we can Tm can be written like this. Okay, you have taken this.
Yes, sir.
Shall we go to next slide?
Yes, sir.
Now, this can be further written as T motor equal to S square into theta into IE plus S into theta into KD equal to, I can take here also you have S and here also you have S square in this one. I can take S into theta out. That means this S and IE will be here, KDE, where the KDE is nothing but Kdm into gr square. This equation we are trying to minimize. We can write like this: T motor equal to S square into theta into IE plus S into theta into KDE equal to S into theta into S into theta whole thing multiply S into IE plus KDE, where the KDE can be written as Kdm plus gr square by Kd naught. That is called this term. And similarly, IE is called as the Kd is called the effective damping coefficient. Okay. Similarly, IE is not a effective moment of inertia. Is nothing but Im plus gr square. So I can write the transfer function of the motor driving a load through a gear. The transfer function can be written in terms of theta motor divided by the theta T motor, right? Theta motor is the output speed of the motor. Torque is the denominator. Is the 1 divided by IE divided by S into K plus E. So this can be represented as a transfer function. I told you transfer function is generally written inside a box. The whole thing will be written inside a square box. input is given the left side arrow, output. So this is how generally we represent the gear system. What you can expect is, for example, you'll be asked to derive this equation and the values are given. Okay, what value I0 is given, KD is given, KDM is given, IM is given, correct? And gear ratio is given, GR is given. Then you will ask to find out what is the torque, motor torque. This is called as sizing the motor. This is also in industry they call sizing the motor to drive a load, which requires higher torque or higher speed. Now, that depends upon, there are two types of gears. One is called step up gear, other one called step down gear. Okay, so when you talk about this, whether you want to step up the torque or step up torque or step down torque, or step up speed or step down the up and this one, both the step, sorry, this is step down. This is called step up. Correct. So accordingly, you have to select the appropriate gear so that you'll be able to drive. Right now, as per the exam is concerned, see, whole idea is how to develop mechanical. That's what we are seeing till now. Correct. Modeling a mechatronic system, modeling a mechanical system. Model here. This is a mechanical system only. Motor, gear, load, all those things mechanical. And only thing is here, I'm trying to find out the motor torque to drive particular load having this much. Correct. Moment of inertia this, motor is this one. What should be gear ratio? You can find out. Or correct. And that can be found using these equations. Any doubt in this? Okay. Next, the mechanical system is, we have another mechanical system, power transmission called rack and pinion. This one, correct? Many of those, the main reason is rack and pinion is used for converting the rotary motion into a linear motion or reverse also. This is called as rack. This is called as pinion gear. Correct? Rack also has the gear. Please note that this is nothing but you have one more gear which was like this. Correct? Which was like this. I cut somewhere and stretched. Cut somewhere, I stretched. Correct? The rack is nothing but gear cut and stretched in linearly. Correct? But same gear profile will be there. Both are same, can be this one. Then other one is pinion gear. Now, if I attach a motor, and if the motor is rotating, correct? So the gear will rotate. Then what will happen? When the gear is rotating, angular velocity omega, correct? With the omega, this will with a linear velocity v of t. The rack will move this one. So motor rotate clockwise, this will move like this, and otherwise it will move both sides depending on direction of this one, clockwise. So the main job of the rack and pinion is to convert the rotary motion to linear motion, or I can do one thing. I can move this rack, correct? Yeah, linear system is there which is moving left and right. Then I want to convert to this is my load. Load is require a rotary motion with the torque. So I attach load to my pinion and I move this one using an actuator, linear actuator. Then when the actuator moves this one, the pinion will rotate automatically. It will rotate with the angular with this one and inertia, correct? So that's possible. So you can do both linear motion to angular motion or angular motion to linear motion. That's the job. So again, it is a gear only. Please note that rack and pinion also gear. I told you one gear was cut and put as a linearly stretched. Other is still this one. So it is a gear only. What is gear ratio in that case? If I say both are this one, gear ratio equal to omega of the pinion gear, speed of the pinion gear divided by the speed of the rack. This is angular velocity omega. This is linear velocity equal to 1 divided by r pinion, where r pinion is the radius of the pinion gear. Correct? The gear ratio of the rack and pinion is nothing but 1 divided by diameter of the radius of the pinion gear. So this is what this one. This we will see frequently. Now that we saw mathematical modeling of many things, correct? Many systems. Starting from, I just want to close this because we started the basic elements of mechanical thing, correct? A machine can be anything which will have individual elements connecting together. They are called kinematic pair. Then they become kinematic chain. Then it become a mechanism. Small mechanism join. You have the machine, right? So the basic elements are spring element, mass element, damping element. The spring element is called as a elastic element. Also, it can store potential energy. Mass element called inertial element. Also, it can store dynamic or kinetic energy. Other name is kinetic energy. Then third is damper. It is called a friction element. It is energy dissipating. Then we saw passive. All those things we look into. Then how to model the spring. Spring can be applied with force or torque. Twisting force still there will be it has a stiffness K, and this is angular rotation. This is linear displacement. Correct. So this is the mathematical model of spring in terms of torque and theta or force and displacement. Already we saw. Then ideal spring, it can store energy. It doesn't have mass, does not dissipate any energy. Springer can only store potential energy. It has a linear behavior. So the transfer function is 1 divided by Ks, where K is called a stiffness or the friction. And it can store how much energy? E equal to C into F square divided by this one can be written as K into X square, where Ks is the stiffness, X is the displacement. Correct? When I apply a force, how much displacement happen? That square divided by 2 is called the energy storage. But practical spring, correct? This is how you represent the transfer function of a spring element. Correct? So the transfer function output divided by input. Output is displacement divided by input is force is 1 divided by Ks, which can be written as C, where C is called compliance of the spring. Compliance of spring, which is equal to 1 divided by stiffness, Ks. That's why you can do that. So practical spring has some inertia and also friction because it is made of some material. It has weight. Weight is there, automatic inertia will come, and it is non-linear in nature. And then we saw damping element. Damping element produces a damping force. Generally, it is a piston moving inside a cylinder with a gap between the piston wall and the cylinder. The radius of the piston will be smaller than piston will be smaller than the radius of the cylinder. So there's a small gap. It will be filled with fluid or air. So when piston moves, the fluid will go from one chamber to another through the gap, and the gap width and also the viscosity of the fluid decide what you call damping force. And then we also saw different type of frictions: friction, kinetic friction, and we saw that. Then the transfer function, how to develop transfer function already we saw. Fd is called damping force, is nothing Kd, which is called damping constant, multiplied by d by dt of x of t in case of linear damper. If it is a rotary type of damper, Kd is damping constant. The torque, damping torque equal to Kd multiplied by d by dt of theta. How many degrees the damper vane is rotating. So that can be written in terms of this one. Then we also saw power. How much power will be dissipated in the damper? Damper is a energy dissipating element. Already we saw that. Then also we saw different type of friction, how it looked. And then we saw mass element. Mass element is a kinetic energy storing device. And we know that F equal to ma. From that, always you can say m multiplied d square by dt square into x of t, where is the displacement of the mass element. Actually, the acceleration. So from that, this is a transfer function in Laplace. And use, we saw that it is used as a flywheel wherever you want to smoothen. And also, it will be when we are going to talk about sensor Monday, we'll see that it is used for accelerometers. Also, it is used. See, mass element is used in also. Then we talked about moment of inertia, all the basic reasons. Then we saw what is moment of inertia in terms of rotational machine. The transfer function already we saw. This is a basic element. Then we consolidated what it is. Then we saw developing a system, modeling a system, mechanical system having mass and spring. So this is a spring mass system. So this is the mathematical equation or mathematical model in time domain. From that you can develop the Laplace. From that you can find the transfer function. Same thing, spring and damper system, which is called a shock absorber. We saw how to develop the mathematical this one. Transfer function, this is nothing but G of S is output divided by input. Output is a displacement of the spring and the damper together, and F of S the force applied input. So transfer function already saw. How to calculate time constant. The equation also we saw. KD divided by K. Okay. Then we saw spring mass damper system. 3 elements are connected. We are increasing more number of components. So 3 system becomes complex, or this one. So this is the time domain equation converted to Laplace. So the transfer function, which can be finally written like this, in which you need to know this also. Please note that these derivations, suppose draw the functional, the sketch of the spring mass damper system showing this picture, derive the mathematical model, time domain, from that derive the Laplace, then and value, if the values are M, K and KD are given, calculate time constant, damping constant, CC. You may get some simple problem. So together you may get 2 or 3 marks questions in exam. Okay, then we alter torsion bar. What is torsion bar? We saw it. Then different type of torsion vibration damper using viscous fluid. Then we talked about modeling the actuator. Started with motor, hydraulic motor. Hydraulic motor, the pressurized fluid with a pressure and the flow rate. And because of there's a torque and angular, this one, the related functions are given. Correct? Transfer function also we developed in terms of pressure versus torque and pressure, the flow rate versus angular displacement of the motor shaft. There are 2 transfer functions, the relationship is shown in the equation. Similarly, hydraulic cylinder with general linear force, we saw how to develop the mathematical model, basic this one. Then the same thing is controlled by a valve. Then how to develop the transfer function, we saw it. This was shown here with full, correct, basic equation, correct. The pressure is supplied, that is going to move the power cylinder, that is controlled by this valve. And we saw the complete equation, including again. Please note that all these things you be asked to derive the equation, also find the time constant, damping constant, and critical damping and damping ratio. You may be asked to find all these things deriving these equations. So then we saw electrical system, RC circuit, RLC circuit, how to develop the transfer function. Also find out again damping will be there. Right? This is called critical damping and time constant T. Correct? T time constant, please note down time constant T equal to root of RC, note down. Because you can see here T square is nothing but RC, correct? That is, yeah, RC. So this is root of RC is going to be time constant. No, sorry, extremely sorry. Here it is the CL. In RL circuit, the time constant T is equated. This should be equated. S square is there here. So that means T square equal to CL, T equal to root of CL. And this is critical damping CC. And this is delta damping ratio for RLC circuit. Then we talked about field control DC motor, how it worked, how to get the transfer function, and armature control also we saw. Then we saw gear and gear driving the whole system. So I stop here. Okay. Next class we will see on Monday. Did it time? Shall we stop or shall we take some more time? Or 10 more minutes or 15? Arunachalam, Chidambaram.
Yeah, we can
Yes.
continue, sir. Yeah.
Yeah. Just a few more minutes. I will complete it more. Now that we saw modeling the mechanical system, modeling the actuators, modeling the gear system, and all the hydraulic motor, all this thing, electric motor. So if I have a mechanical system, this table shows equivalent terms in terms of this one. So spring, you can say that it can store potential energy. In electrical system, the potential energy stored by capacitor. The equation also given. Q is the charge in the capacitor, and the C equal to capacitor value voltage. If I take a capacitor is represented like this, C is the capacitance. There's a voltage stored in it. Voltage is across this plus minus, and there's a charge. They are connected by the equation. Charge in the capacitor equal to C into V. Capacitance value in farads. This is in given in farads or microfarads or millifarads or nanofarads. Capacitance value can be anything. This is voltage across the capacitor. I can say VC. This is how it is related. So it is a potential energy storing device. Potential electrical energy storing device. Spring is a potential mechanical potential energy storing equation. Already you know what is the equation. Already you know spring. Correct. Similarly, if it is a thermal capacitor, correct, thermal energy you want to store, correct, reservoir. So that reservoir, the amount of thermal energy stored in joules equal to, this is the capacitance of the thermal source multiplied by delta T, temperature difference, correct. That is the thermal capacitor. Fluid capacitance, for example, I have a reservoir. I have pipe connected to a reservoir, right? So pipe is going. So fluid is going there. This is called reservoir. Correct? Fluid reservoir or storage tank. Nothing but a storage tank. Correct? M is the amount of fluid is going to be C. Capacity of the reservoir multiplied delta P. Correct? This is called as fluid capacitance. Similarly, in case of mechanical system, the energy will be dissipated using a damper. Already we know the damper equation. Fd equal to kd into d by dt of x is nothing but velocity. If it is said that is linear force, and so, angular force means td equal to kd into omega, velocity, angular velocity. That is what this one. Similarly, in case of electrical system, resistor is the energy dissipating. Here damper, in case of electrical energy, resistor energy dissipating. The voltage across the resistor is R into I. This is called, we call it Ohm's law, correct? V equal to R into current flowing through the resistor multiplied resistance is called voltage. This can be written as voltage equal to R into d by dt of Q. What is Q? What is I? I is nothing but d by dt of Q. Q is called the electron charge. Electricity is the flow of electrons. The rate that is the charge is moving in the wire is called I, current. That's what Chi. So this is nothing but I. Right? D by dt of Q is nothing but I. So this is a energy dissipating, resistor energy dissipating. Okay. Then thermal system, there's no equivalent to this one. Only thing heat transfer. Correct? Heat transfer with a conductor. That can be equated to a energy dissipating, I mean, heat loss, correct? How much heat lost is dependent upon the temperature resistance. No? I take a metal, correct? Metal has how much resistance it offers to the heat flux, right? This is the resistance heat flux. This is nothing but heat flux itself. Phi is nothing but heat flux, is nothing but temperature difference. Okay, so in case of fluid system, fluid friction law don't conform to this one, damping this one. We have correct already. We have talked about it. Then, if I talk about the force in mechanical system, force equal to mass into acceleration, which can be written d mass into d by d square by dt square of displacement. In case of electrical system, voltage across inductor, correct? Voltage across inductor VL is equal to mass. Correct? Induct is equivalent to mass in this one. We know that mass element is a kinetic energy storing device, mass. Similarly, inductance is a electrical kinetic energy storing device. Is going to be voltage across inductor equal to L into d square by dt square of Q. Correct? So that is nothing but the voltage stored on the inductor. So only when current flow is the, since Q itself is the rate of, correct? Current is the d by dt of Q, correct? And this is d square by dt of this means only when there's a change in current, correct? Then only energy is stored as a magnetic field. In inductor, please note down, energy is stored as a magnetic field. energy is stored as magnetic field. Magnetic field will be there only when there's a current flow. If there's no current flow, that means no magnetic field, no energy. That's why the index is called a kinetic energy storing device. In mechanical system, if there's no movement, correct, the mass will not move or the mass will not rotate. If it is no rotation, no movement, automatically energy is not stored. According to force equal to mass into acceleration. If there's no movement, acceleration becomes zero. Angular acceleration and linear acceleration, automatically the energy stored in the mass will become zero. That means only moving mass have the kinetic energy or dynamic energy. Same thing in this case. There's no equivalence in thermal system. In fluid system, we have delta P. Change in pressure equal to L into D square by V. This is volume. Correct? Change in volume. V is called a volume we are talking. So in case of conservation energy, mechanical system, we talk about the correct total force acting on a system equal to zero. Similarly, total moment acting on a mechanical system equal to zero. They're called D algebra. In Kirchhoff's law, current, for example, I have 3 wires, correct? One wire current is entering, another wire, another current is entering. Then in this, because we have Kirchhoff's law applied to node. Node cannot store any current. So the current has to go, I call I3. I3 equals I1 plus I2. Correct? So summation of total current, if summation of this will be 0. Similarly, law of conservation thermal system, we will talk about net energy, thermal energy stored equal to 0 in a system. Similarly, law of conservation of energy for fluid system, it have mass equal to 0. So this table shows what the different system equivalent. We are trying to find out various elements in different system, equivalent systems. Spring, electrical capacitor, thermal capacitor, fluid capacitor, they are all same function. Damper, resistor, correct, heat conducting plate are this one, and also here there's no equivalent. Newton's law, we can see whatever we saw consolidated. I think I'll stop here. Okay.
Yes, sir. So we'll cover up in Monday, sir.
On Monday,
Sir,
because already you have to go. Today, this is an
Sir,
extra class. That's why I thought of stopping by.
Sir, just one request, sir.
Yeah, please.
Sir, shall we consider the syllabus up to today's class? Or you want to continue up to for the mid-sem?
No. Up to Wednesday, no other option.
Okay, sir. Okay, sir. Okay. No issue.
Already question paper is set and sent.
Okay. Sorry, sir. Okay. No issue.
No, don't worry.
Right.
But it is going to be light syllabus only. Don't worry. But please
Sir,
attend the classes.
Sir, one more. It's a simple
Please
request.
tell me.
Shall we take some formula sheets, sir? That is what formula sheets.
Formula sheets are not allowed. Generally, we don't allow.
Sir. Right, sir.
Sir, one more request if we can put, sir. Can we get any reference question paper or something so that we will have an idea about the exam, sir?
No. Because reference question, because we're going to, I told you, define, derive the formulas. Or I will give, for example, I told you, derive this equation, correct? Motor,
Okay,
derive this equation,
okay,
or derive this equation and the value of mass and this one spring stiffness, correct? And these constants are given, valve constant, all this thing again. Then compute the time constant T, correct? Root of m by 4 kV, correct? Cc. Find the damping ratio, time constant. Simple, only nothing more than that.
Okay. So derivations are also expected to come, sir. Like these derivations, whatever you have taught, sir. So those are also expected to come, sir.
Yeah, any derivation will come, correct? So derive this, for example, and then calculate this, correct? So
Understood.
This question may be 3 to 4 marks or 5 marks. Because 30 marks is exam.
Understood.
90 minutes. Lot of time for you. But the Monday, Tuesday, Wednesday class you have to attend. There's a portion coming from that also.
Sure, sir.
Sure, sir.
Okay.
Understood, sir.
Understood, sir.
Thank you.
Okay, sir. Thank you.
Kind of you. Have a nice weekend. Enjoy your trip. or you stay where you are, Dasara holidays. And
Yes, yes.
another thing, in between somebody talk, don't take it very this one. It is not something to say what I want. I am not hard with any of you. Correct?
Yes.
Thank you, sir. Thank you, sir.
You all
Thank you,
know
sir.
about me. I only thing is, if you don't listen, you are going to waste your, chance is given to you. Don't waste the chance given by company. Learning as much as possible. That's what my interest.
Sure. Thank you for your support, sir.
Noted, sir.
Mm.
Yes, sir.
Okay.
So
Thank you.
kind of.
There are two things. My role is one thing is as a teacher. I'll be very strict, but as a coordinator, always I handle everybody with glove, correct, soft glove.
Sure, sir. Thank you. Thank you, sir.
Kind
And
of.
have a good weekend. Yeah.
Yeah, same to you.
Thank you.
Give the attendance before leaving.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Okay. Thank you. Bye.